Okay, good afternoon, folks. My name is Krishna Mayuram. I'm here today to talk about, we picked up a beta version of OSP 8, and that's based on Liberty. I'm going to show you what we did, especially for Hadoop as a service. So this is a very common thing, Hadoop as a service, but there are some challenges, especially if been using Hadoop, especially with OSP. That's kind of challenge trying to solve. This is probably most of the things could be similar, but what we are trying to do with OSP 8, how are we taking advantage of the beta, and we are going to have the GA version of this will be available in Red Hat Summit, which is going to be in San Francisco in about a month. Right? Today we are based out of our version which is on beta. Okay, so this is a short introduction. So what we are going to do is basically the agenda would be like we are doing Hadoop overview. What's basically Hadoop is? It's then what we talk about is OpenStack, and also what is that we are doing with UCS. How is the UCS is Cisco Unified Compute Systems? How is it optimized for performance, especially for big data workloads? What we call as big data bundles, architecture bundles, all the way from starter kit to the extreme capacity, which can go up to half a petabytes in one rack, and how it is optimized, especially with OpenStack, Red Hat OpenStack platform, and how are we using OpenStack Director to provisioning, managing all these VMs. And also we'll talk about Iconic, but right now we are not ready. So we will be doing Iconic based somewhere in that is OSP Mitaka. It's about OSP 9 or 10 time frame, right? So Hadoop, basically, Hadoop is basically the distributed file system. Today, Hadoop is becoming more and more a storage for all kinds of data platform requirements, right? So it's no more just when we started, I used to be at Yahoo some time back. We started 0.5, then it was purely used for distributed computing to do the unstructured data, to parallelly compute them and get some results. But today, Hadoop predominantly becoming the next generation database file system. If you want to store data, it's Hadoop, right? So you get all fault tolerance, resiliency, distributed, etc. I'm going to have one slide which talks about the traditional compute models, especially in the large scale distributed database processing versus what's going to happen in non with a distributed computing model versus traditional, right? Oh, sorry. Yeah, that's true. Okay, so sorry. So this is a kind of the ecosystem. What do we want to call? The ecosystem consists of what we have is the storage. HDFS is storage. We're talking more on Yarn, which is yet another the next generation of processing. Like scheduling and the processing and schedule are being distributed. So on the top of it, we have variety of tools, so which enables the consumption of data, and also we have schedulers, and also we have data collectors and data aggregators, right? How do we harvest the data and pump it in and take it from there? On the top of it, we have Ambari for the management. So now let's talk about what is Hadoop as a service. So traditionally, Hadoop installation takes weeks, several weeks to days to months. But with this approach, what we are providing is a Cisco verified designs, which will enable faster deployment of Hadoop, right? Not only faster deployment of Hadoop, and also we are highly optimized. And also, I don't want to talk what we're going to do in future, especially with the bare metal. Right now, it's all VM based, using OSP 8 beta. So then also we'll provide chargebacks, extra, etc. Pay as you go, multi-tenancy, right? So these are the important things like self-service provisioning, because you come, you go. Basically, there is a workflow authentication. I go as a developer, I request for an instance of Hadoop. You will get a small 3-node Hadoop. Immediately you spin off once you are approved. You don't have to wait for any DBA or a sysadmin or a lot of infrastructure guys to wait for a week or so to get an instance. If you are a data scientist, you quickly spin off a couple of terabytes of Hadoop instance, and then you start working on it immediately in a couple of minutes, or maybe under an hour. And then we are talking about elastically scaling. So this comes to I'm going to talk about what we call as the domains, how we scale. We have reference implementations which goes all the way to close to about 1,000 node installation of Hadoop, right? And also I'm going to talk about how do we scale them today. I mean, what kind of secret sauce we have to scale them, right? And also we'll talk about next is how this kind of infrastructure facilities are utilized to make this happen. And also it is, as I said, pay as you go. That means you don't have to pay today. You are going to start with a starter like a couple of nodes, then you will be a couple of 100 nodes. So you scale as you go. And also it's composable. If you don't want, just bring it back. Very much similar to Amazon, right? So this is a typical OpenStack architecture. It's very standard. There is not significant changes in OSP 8. We just follow that. We have IaaS. We talk about compute, network, and storage. Then we have the monitoring, which is Ceilometer. We have data processing, which is Sahara. And also we have the orchestration, which is Heat. And we have the dashboards, basically the UI. And also the what we have is the Keystone is basically for the identity. So interestingly, we have some new features of identity being added in OSP 8. Yeah, this what I mentioned is, so what is each functionality of that? If you look at it, OSP 8 is going to give you, you have a dashboard that is Horizon under what are the capabilities, and you have the compute, which is Nova, and also you have the network, which is Neutron, right? And then we have the shared services and the storage, the Cinder, and also you have object storage, which is Swift, and also we have Glance, which is image files. This is part of storage, but it comes as a service, and these are the services we have got, which is very much standard. So this is the one which I was talking about. This is what happens in a traditional computing model, right? So what would happen is the whole database used to reside on a huge servers. Then your workloads will always be computed in a single place. That means if you look at traditional relational databases, right? So what is the best thing? You have to completely, even though any database, relational databases, so they will do the processing. So they're all sequential. They cannot be parallel. So with the Hadoop, this is basically, this is the end state. You have divided the job and brought the database, and also database is spun into small pieces, and this is where you are, right? So you have number of data nodes are spin into small pieces, and the distribution happens, and the processing happens, and the map reducer, the way it works is it maps and reduces simultaneously or in parallel on all the nodes. So what is the value proposition for Cisco? So, so one of the important thing is Cisco gives you validated designs. That's an important thing. And if you see on the right side, it's called a domain. One domain, and second thing is ACI. So use Nexus 9K, the switches, and you have Fiber FI, plus with ACI, the whole service profile makes everything, automation is pretty simple. So you create a service profile for each type of infrastructure, and you are automated. So you can boom, you can create, install the instances pretty quickly. And second thing, if you look into the whole infrastructure, you can add the disks. They're all like kind of sessionless, right? So basically you can add and remove, and the ID of that device, the GUI ID is controlled by the FI, automatically assigns that. That means it's like a stateless, sessionless kind of environment you have, where you can do a plug and play of the disk with more ease and comfort, right? And now, and also you can scale. So you can go from that. The next slide says different storage configurations to go all the way from starter. And this one, to remember, on the extreme right is the one where you can see the whole 5 petabytes, half a petabytes to beyond 50 or 60 petabytes, or much more than that, right? Depends on the amount of storage. So this is the architecture bundles you have. On the extreme left, you have a starter kit. On the extreme right, which is very high performance, 3160. On the extreme left, it is 220 or 240s, right? So we have both capacity optimized and also performance optimized. So the reason for the capacity optimized is, so some of the information, things like NoSQL databases, you want to run Cassandra. We also do a lot of things like Cassandra, MongoDB, Spark, and Splunk. All those things are running. Splunk for log analytics. So traditionally, these things are actually a reference architecture is created by doing certain kind of optimization, very much optimized for the UCS, Cisco UCS. So we are almost close there, and so these are the kind of partner ecosystems you have, which will give us flexibility and also will give you the best of the breed technologies adoption with the UCS systems. Okay, so we are on the top of the hour. Thank you very much. Let me know if you have any questions.
So I have one question. So you basically put Hadoop into one of the gigantic box, UCS from Cisco.
Right.
So what's your advantage comparing to the commodity